Now we're going to wrap up this section with some final topics and logarithmic graphing. So this first one, it says, what is the vertical asymptote of f of x equals -2 log base 3 of x plus 4 plus the 5? And so that -2 is going to stretch it and reflect. Okay, that's nice to know. This 5 is going to shift it vertically. But what is it? What's the 4 doing? The 4 is going to cause the horizontal shift. And that's what's going to be affecting the asymptote. So normally our asymptote in a standard function, or the parent function we'll call it, it'll be at x equals 0. But now it's going to be, for this function, the vertical asymptote is going to be at x equals -4, because it's plus 4, so it goes to the left, -4 to go to the right. Okay. The last little topic here is find a possible equation for the common logarithmic function. So we're going to try to find a graph for this, or this is the graph. We're going to try to find the equation for this. And being common log, so we'll just, they're telling us it's log base 10. So our formula is going to be something of the form f of x equals, we see how it's shaped, normally come from below like that. So given that where it's coming from, it's going to be a negative times some a, common log of x, and I see which way it's going. It's going to the left, so x plus b, and then I have a plus k, or plus d, whatever you want to call it, doesn't matter, just some other variable. So I'm looking at this here. It looks like this x equals -2 is the asymptote. So I think I'm going to change this and make, say, f of x is -a times log of x plus 2, because it goes to the left, plus k. So looking for a couple of points, and I see right here at -1, 1. I'm seeing something here at 2, -1. Let's use those points to see if we can fill the rest of this in. So if we try the -1, 1, be 1 equals -a log of 1. Sorry, the x was -1 there. -1 plus 2 plus k. And log, well, it's going to be 1 equals -a log of 1 plus k. Well, log base anything of 1 is 0, because anything to the 0 is going to be 1. And I don't want to get an argument about, oh, log base 0, whatever. And we don't do log base 1. But my point is that this part here is just going to be 0, so we get 0 for that. So it's 1 equals k. So we know that we have f of x equals -a log of x plus 2 plus 1. So let's go to the next point that we have, and that's at 2, -1. Excuse me. Excuse me. Sorry about that. -1, it's a y value, equals -a log of, our x would be 2 in this case, so 2 plus 2 plus 1. So I subtract 1 from both sides. negative 2 equals negative a log of 4. So I can divide both sides by log of 4. That divides out. So negative a is negative 2 over log of 4, or a equals 2 over log of 4. So I guess if we put this all together, it's not very pretty, but our f of x is going to be, still have that negative out front, negative of 2 over log 4 times log of x plus 2 plus 1. Okay, not quite what I was hoping to get, but there's your answer. This is the equation that would satisfy this graph. Okay, and I believe that's it for this chapter. Or for this section, excuse me. We still have some more.